Hello and welcome to this clip going through a slightly more difficult level response question. You can see at the bottom that it says high, medium demand. This sheet is from a set of exemplar questions and worked answers that are from the OCR Chemistry A website in the resources section. And it would be useful to have the OCR Chemistry A periodic table and data sheet to hand whilst we go through it, because obviously we'll be looking at the infrared spectrum and be looking at the information table on infrared spectra and wave numbers to help us work out what this compound is. Okay, so let's see what it tells us. It says a combination of mass spectrometry and infrared spectroscopy can be used to determine whether pure pivalic acid has been made. So you probably won't have heard of pivalic acid, and that's on purpose. So that's the first challenging part of the question. They mention something that won't have been in anybody's textbook. But they do give you spectroscopic data. And for that reason, you can use the spectroscopic data to deduce various things about the molecule. So let's have a look at what it is we've got to do. It says the student claimed that the combination of the mass spectrum information and the IR spectrum would show that pure pivalic acid has been made. It says analyse the evidence using the data sheet, the mass spectrum data, and the nature of the compounds involved in the synthesis to comment on the validity of the student's claim. So starting with the mass spec, you can jot down that the base peak is the most common fragment and the largest MZ value will represent the MR of the compound. Then if you move down to the infrared spectrum, you can see that there's 3 bonds that are typically found in the carboxylic acid functional group, in other words COOH. So it's always a good idea to spend a couple of minutes planning what you're going to write, so then you can construct an answer. So what I'll need to do from here on in is clear a little bit of space on the right hand side. So now what we can do is use the wave number information from the data sheet to work out how we're going to answer the infrared spectrum part of the question. Okay, so we can have a look at, so the 3 things I think that we need to talk about. The mass spec, the infrared, and a comment on the validity of the student's claim, which is that pure pivalic acid had been made. So let's start with the mass spec. So the first thing to think about is that the compound has COOH. If COOH came off as a fragment by itself, it would be MZ equals 45. We're not told about any peak that says MZ equals 45. We're told about a peak that says 57. So if we look at the difference between 102, which is the largest peak, the molecular ion peak, the difference is 57. So 57 must be the remainder. So with our 57, if we insert carbon and hydrogen into it enough times, we end up with C4H9+. So it's worth just adding something to what we said a minute ago, was the idea that 57 must be the remainder of the molecule. In other words, you must have lost COOH, so it must have broken at where the COOH group was bonded onto the rest of the molecule. Now the infrared is quite straightforward. We could technically leave it just with the OH, the C double bond O, and the C single bond O sort of labelled on the spectrum as we've got there now. But let's put something in under infrared so that we can talk about it. So we need to put that in so that we can show the examiner that we've used the data sheet and matched the 3 bonds that are present. So comment on the validity of the student's claim. Now, if you think about it carefully, let's now focus on the OH carboxylic acid. So that very end part of the OH peak actually falls within the wave number for alcohol. So if you look at the data sheet, extract 3,200 to 3,600. So if there's an alcohol present, that must mean that it's an impure sample. So to mention that in your answer will allow you to say that the student's claim isn't quite valid because of the that left-hand part of the carboxylic acid peak actually goes into the alcohol wave number area. Okay, so that finishes off this question. Hopefully you found it reasonably useful. Let's have a little look at the mark scheme now. So, looking at level 3, we've used the IR spectra, we've used the mass spectra, and we've fully supported the conclusion that pyruvic acid is made. And we've suggested that the evidence says it's contaminated with an alcohol. We've mentioned that MZ102 is the MR. We've mentioned that the base peak of 57 must be a fragmentine due to loss of COOH. We've made reference of the IR absorption below 3000 and also talked about the 1700 to 1725, or a number in that range, is the presence of the C double bond O. Now we use the range straight off the data sheet. That falls within the range, so that's okay. And the broad absorption above 3000 suggests an alcoholic OH from step 2 of the synthesis. So the important thing to remember is all I've done is one possible way of representing the answer. There's lots of different ways you could pick up these marks. So looking at the mark scheme, it's really important to look at how the hierarchy of the levels work. So the more clarity, the more flow, the more logic you use in your answer, the higher the levels you go. And the quality of the science, the quality of the chemistry that you put in your answers decides whether you get the lower or the upper mark. So hopefully this has been a useful look at this question. Thanks again for listening, and until next time, see you soon.